for more on the mission. Miles?
Sophia, the spacecraft not too long ago turned around. No, it's not heading back to Earth. It just turned around to present the business end of it, if you will, toward the atmosphere of Mars. This is a little piece of the heat shield, which is made by Lockheed Martin. This is tried and true stuff. It's basically essentially glorified cork. And this is what will go on the leading edge, if you will, of the spacecraft as it enters the atmosphere of Mars at some 12,000 miles an hour. Temperature out here will be about 2,600 degrees. On the inside of the spacecraft, it'll be virtually room temperature. Here to talk a little bit about what is going on in space right now as we get a little bit closer to this anticipated landing, a little more than an hour away, is Matt Golombek. He is one of the main scientists involved in this program here at the Jet Propulsion Laboratory in Pasadena. Matt, good to have you with us.
Thank you.
That turnaround maneuver was a critical thing, obviously.
Yeah, turn to entry is basically it's turning the spacecraft so it's oriented at exactly the right angle to enter the atmosphere. If you're too shallow, you skip out. If you're too steep, you burn up. So you got to hit that just right, and you have to control that flight path angle perfectly.
As far as we know, that bullseye is still what we're headed for here. The navigators are very excited about the prospect of landing at the Gusev crater, which looks to all accounts to be a dry lake bed. If we could put a camera on Mars in orbit, this is what we'd see right now, right, Matt?
Yeah, if you could sort of trail it on the way down, you'd see it as the parachute came out, supersonic parachute. That would slow you down to about 1,000 miles an hour. You'd then go ahead and dump off the heat shield, which you've now used that. You don't need it anymore. And the lander is repelled down a 20-meter tether, which you can see it doing that. And now there's a radar altimeter on the lander. We'll look at the surface, measure the closing velocity, determine when to fire the solid rockets and inflate the airbags. There's the airbags inflating. And just before maybe 10 meters, 100 meters above, they will fire the solid rockets. That will bring the entire stack to zero. It will bounce from 10 meters, and it will bounce and bounce and bounce and
so if
a kilometer across the surface.
If you were a Martian, it would be quite a sight to see. Let's talk a little bit about the landing site, which you were so instrumental in choosing. Always a balance between what is safe and what is scientifically interesting. Do you think you've made a good compromise here at what is called the Gusev crater?
Yeah, it appears to be a safe location. You can't even talk about it unless it's safe. A 150-kilometer diameter crater that's been filled up by a channel to the south that looks like it was a crater lake at one point. And here we've put the ellipse in the center part of that crater to try to get at the lake sediments.
All right, it kind of looks like a cigar. Hopefully they'll be close and there will be a cigar. Live pictures of the control room. The guys in there don't betray it right now, but I suspect there are a few butterflies in their stomach as we speak.
Well, all those guys are busy. It's the ones of us who aren't that have the butterflies.
Better to be busy. All right, Matt Golombek. We're watching it as it goes down. It is now less than 8,000 miles away from the surface, traveling quite literally much faster than a speeding bullet. A lot has got to happen in the coming minutes, and we're watching it very closely, Sophia.
Miles, thank you. The Vil-2 comet flying through the tail while collecting samples of dust and gas. The matter could be left over from the formation of the solar system. And that interstellar intersection, by the way, took place 242 million miles from Earth. Still ahead here on CNN Saturday Night, one of baseball
of course correction maneuvers because it looks like they'll hit a virtual bullseye in the targeted landing area. The real trick will come in the final 6 minutes of the journey when the spacecraft has to slow down from 12,000 miles an hour to zero. There's a lot of intricate procedures to make that happen.
When you take into account how far we've traveled and what our target at Mars is, it's kind of like playing a par 5 hole in golf where you tee off in Paris and the hole is in Tokyo with a little water hazard at the end.
The rover is supposed to send back a radio signal once it's in place. If NASA doesn't hear anything by late Sunday, the mission may be over. Spirit is supposed to spend 90 days analyzing Martian rocks and soil looking for evidence of water. NASA did 49 miles of the Vil-2 comet Friday. It took a snapshot of comet's nucleus and 71 other photographs. Stardust also collected some of the dust particles that surround the comet. Scientists think they could be leftover material from the formation of the solar system. The spacecraft is expected to eject the particles to Earth in January 2006. Several flights over the...
And one of the first things it does is sending that data back in real time. And if it picked it up, it could be in the MGS Mach buffer now, and it will be sent back very shortly. And that would tell us a tremendous amount about what actually happened during descent.
And we're seeing in the foreground there, right part of your screen, NASA Administrator Sean O'Keefe. Middle of your screen with the glasses, blonde hair, Ed Weiler, who is Code S in the NASA vernacular, head of the science mission for NASA. Conferring with some of the key people involved in the mission. Pete Theisinger, who is the project manager here at the Jet Propulsion Laboratory, conferring with them, probably having a similar discussion that we're having.
Exactly the same one. What's happening and what can we expect next, and how's everything look?
And you know, it is, we just saw that the joy in there when they heard that tone on the surface. There's got to be a little tension that comes at this moment.
Still searching for the signal.
So we believe it's come to a rest now. It's probably done rolling, and now they're looking for that second series of beeps after it's come to rest. So this will be fairly important here.
Let's look once again at where Spirit was headed, the Gusev crater, as we look at some 3D animation of the red planet. And this particular spot, not too far from the equator, it is the Martian summer right now. It's about 2 in the afternoon, if you will.
4 in the afternoon. It's about 15 degrees south.
And what we're looking at, here's the outlines of this crater. And this crater is about the size of Connecticut, correct?
150 kilometers across, and of course when it formed it would have been extremely deep.
That is the bullseye.
That's the bullseye, and that's what we think it would be the lake beds that were deposited by that channel, Ma Dim Vallis, that you're now outlining there.
But this is what's interesting too, is it's hard not to look at that and say that isn't a river pattern of some kind.
Some sort. There's even some deposits that look like a delta near the end of where that comes into the crater. So that was all very suggestive for when we selected this landing site.
Now, the crater itself would probably have been formed by the impact of an asteroid or something many millions of years ago. What makes us so certain that was water? I mean, we might look at it and say, of course that was water, but there are probably some other explanations that work too.
It's an 800-kilometer long channel, and it drains from the ancient highlands all in a downhill direction. So it goes in the direction you would expect. There's a lot of indications to imply that, really water is the thing. There are exotic fluids that you can think of, but none of them really kind of fit the bill the way liquid water does.
It's just hard to imagine Mars with water. It is such a horribly dry place right now. It's hard to...
I have positive confirmation of more than 240 kilobytes of MR data.
Okay, now once again, that is coming from the, in this case, it would have been the Global Surveyor, Mars Global Surveyor, one of the satellites that NASA has orbiting the planet, indicating it has a waft of data that they're getting in right now.
That they obtained information from MER during descent, and it's on board the spacecraft, and it will be sent back fairly shortly.
You're looking right at your screen in the American flag shirt. That's Wayne Lee. To his left, Rob Manning, a couple of the key people involved in this mission. Wayne Lee, entry, descent, and landing, the chief engineer, and Rob Manning, also the entry, descent, and landing development manager. These guys, this was their moment in the sun.
Yeah, absolutely, no question.
Yeah.
So those are the guys.
Now, as they go through looking at these screens and culling this out, when you're looking for that 15 watts worth of information, is it easy to overlook it?
No, if they saw the signal, they'd be pretty quick. They can ferret out the signal from the noise. So if they saw the signal, they may not understand what the tone was or what it was saying, but the signal would be fairly obvious. So.
And do you recall, it probably seemed like an eternity to you, but the gaps in Pathfinder, how long it was before you had...
Well, actually, after it came to rest, it was base pedal down. We saw it. So we saw it a little bit sooner than this.
Okay.
In lock, receiver
we
in
are
lock,
told...
earliest is at 04:24:57. Latest is at 04:28:57, which is considerably after the expected landing time. I'm still waiting to get the second chunk of data. Stand by.
Copy that. let us know when it's
help us decipher that a little bit.
MGS is trying to figure out when it
Mars Global
received the
Surveyor.
information
Okay.
from MER. So there's a little bit of uncertainty there.
Mike Malin is the person who runs the camera on the Mars Global Surveyor.
And the question they're discussing is whether they receive some of that data after landing, which would be very, very important.
Obviously critical in that respect. All right, that room right now, is there a lot of conversation? We can't hear the auto conversation, or is it pretty quiet?
No, it's pretty, well, anybody who's doing their job, the guys sitting down, they're quiet. They're listening for
during the entry, descent, landing sequence, the Spirit lander
for the vocal box, for understanding what data has been obtained and listening for that tone. The guys in the back are just sort of yucking it up.
Could you verify the broadcast
And the
channel?
reason it is sent back on tones is you only have that 15-watt capability, and there's just not a lot of information that can be transmitted. So tones are the easy way.
Oh yeah, and there'll be no way to lock on to a signal that week. So.
MER A, B5.
Copy that. All stations, this is flight. Station calling flight.
That was me, probably, flight. I have confirmation from Stanford that they saw the signal from the rover for up to 12 minutes.
Ah, Stanford was
I
listening.
mean, they said a couple of minutes. They're not very accurate in their timekeeping, but they saw
Sounds
it
like
for a lot
Stanford
longer
picked
than
up
it
the
would have been
signal
just
for
the-
quite a long
Stanford is
period
one of
time.
the,
One of the radio telescopes at Stanford University.
Okay.
They probably were listening as well.
All stations,
So that
this is
does,
flight.
but that doesn't tell us
tell you a whole lot.
what's going on right now.
And prepare for UHF data on MER A, TIS B4.
We either need the tone from the
UHF
surface,
tracking antenna
or we
Stanford
need the
University reporting
surface
that it may
pass
have
to
seen
MGS,
signal
which
from
would
the
be
rover
happening
at a time
later
at
in
which
the
the
hour.
rover should have been on
Okay,
the ground.
so we may be getting to a point where we're going to have to wait for that pass overhead to see if it communicates. And even if those antennas are sort of out of skew, the satellite passing overhead may be able to capture the signal.
UHF, yes, is oh, wait.
What's going on? Something's... They see it.
They see it.
They see it.
They see it. They got the tone from the surface.
All right, that's fantastic. That is fantastic. All right.
So it worked.
Not bad, huh? You know, 4 years ago, we all sat here and we just watched and we watched, and the Mars Polar Lander never phoned home. It was such a sad moment, and in this case, just the opposite story. And that's just the story that NASA wanted to be able to tell on this evening.
So that implies that it has come to rest successfully. It's sitting, functioning on the surface. It's not rolling around.
Look at Rob Manning there. Look at Rob Manning there. That is a man who has sweated a few moments
Pretty
here.
happy people.
All right. All right. Well, we can say it with some degree of certainty. Actually, pretty good certainty.
Pretty good.
That Spirit has arrived.
Successfully
The Spirit
landed
has
on
landed.
Mars, yes.
And is in the Gusev crater, and not before too long will begin its scientific mission, a mission that could last 3 months, could last even much longer. If all goes well, we should be seeing images from the surface of the planet of Mars, the first we have seen from Mars since 1997, the Pathfinder mission. And of course, the moment we get those in, we're going to share them with you. That could even come within a couple of hours with
Actually, even shorter. By around just after 9 o'clock would be the UHF pass with MGS from the surface. That could contain some of those first images.
All right, 9 o'clock Pacific. Set your watches accordingly elsewhere. That is something we will be watching, and as soon as those pictures come in, we will share them with you. This is Miles O'Brien reporting live from Pasadena's Jet Propulsion Laboratory, a happy place tonight as the Spirit rover is off on its scientific mission after a 303 million mile ride. Matt Gullenbeck, thanks for walking us through that. Congratulations to you. I know you're excited because the fun begins for the people like you, the scientists.
Absolutely. Now we're looking for all the data that we're going to get back. There's a whole wide variety of things have to unfurl and come up and open up before we're going to get data. But this is the the most important first step. So we're happy folks.
It was 6 minutes of hell, as they said, but I would say these guys are in heaven right now.
Absolutely in heaven.
And just before we close it out here, it's worth reminding that a lot needs to occur here for that science to occur. But pedals have to unfurl, airbags have to retract, all those things. Nothing nearly as critical as what we've seen over the past few minutes.
No, the series of events that need to happen now is that the airbags deflate, the spacecraft will actually open up on the surface, the pan cam assembly, the mast with the imager will rotate up to be in an operational configuration. If there's time, it will actually image the sun. It will find the sun, and it will point the lollipop-shaped high-gain antenna. And if all of that goes to very well, we would actually even begin to see information from that. So the sequence you're seeing there on the screen is pretty much what's happening now in the best of all worlds.
It doesn't waste any time when it gets on the surface. Time is sort of the essence of these missions,
yeah,
right?
now that's all it does autonomously. Everything else you're seeing now would happen over the next 9 days, and that's a very cautious sequence where they check out everything long before they ever start to drive off. So.
Yes, we should point out this rover will not move for at least a week.
9 days at the soonest, and it could even be longer than that. So, so we have plenty of work to do, but obviously the most important first step we've done very well.
Scientists I know don't like to use their gut. They like the facts. But does your gut tell you that this suite of instruments on here, all this 20/20 vision, this capability of augering into rocks and sampling rocks, these mass spectrographs that can actually look for emissions from rocks that make them interesting, does that suite of instruments together lead you to believe you're going to find some smoking gun proof one way or another about where the water went or where it might have been?
Well, we have the right payload, and we have what I think is the right landing site. So it's as good a place as any to try. You'd never know, of course, what you'll find when you get there, but boy, this is the right mission going to the right place with the right suite of instruments. So we're doing the right thing.
And if, in fact, Spirit phones home with some, ironclad proof that there's sediment there, proof that there was a lake there millions of years ago, that means there was water, and that means there's a fairly good likelihood there was life.
Well, there was water at least, and then the big question, which the one we need to answer, is any place that you have liquid water stable in the environment, will life form? On the Earth, pretty much as soon as the Earth cooled from the extremely hot, bombarding asteroids, life started at about 3.9 billion years ago. And so if it was wet on Mars, did life form there? And if it didn't, why not? What's so special about the Earth?
Well, you very quickly get out of a scientific discussion and into something much more profound, don't you?
Almost theological. What does it take to form life? Is it a chance in a billion occurrence, or is it an act of God? What is involved in that? And to be able to address that in a scientific manner, this is the right time to be on Mars.
Matt Gollenbach, we'll leave it at that. Thank you very much. I'm Miles O'Brien, reporting live from Pasadena's Jet Propulsion Lab. Back to our regularly scheduled program.